Hello, everybody. Welcome to your 11.3 lesson on interpreting the shapes of data displays. Our learning target for today, we are going to be able to interpret shapes of data displays representing different types of data distributions. We will interpret and compare differences in the shape, center, and spread of different data sets, and we will be able to determine the relationship between the mean and the median of a data set when the shape of the data display is evenly spread, skewed right, or skewed left. All right, so a little bit of vocab today. We have been talking about median already, but let's add in that your median is a measure of center. And I'm just putting that in quotes because that's phrasing we see a lot. Measures of center, measures of spread. The median is a measure of center. It is the middle value of ordered data. All right, the mean. The mean is another measure of center. So if you are asked to compare measures of center, you could compare medians, you could compare means. Those are good measures of center. The mean is the sum of your data values divided by the number of data values. All right, symmetric data. This is data that is evenly distributed around the center. So evenly distributed, what that could look like. Maybe your distribution takes a shape like that, where here's the center right there, and it's evenly distributed. It looks symmetrical. When your data display is symmetrical, the mean and the mean, the mean and the mean, the mean and the median are about the same. And I'm not saying exactly the same, but they're about the same. They're pretty close to each other when you have a data distribution that is symmetric, evenly distributed. All right, so then we have skewed data. Skewed data is not symmetric. The data display will have a I'm putting it in quotations. It kind of looks like a tail. We refer to it that way sometimes. The data display, can I speak today? The data display will have a tail to the right or left of the rest of the data. Okay, so let's talk about that for a second. If you have data that is skewed left, good thing you have some more room on your paper, right? What that looks like is you might have a tail to the left of the rest of the data. So it could look something like that. So we can see here's most of the data. We got this tail off to the left. Here's kind of where the most of the data is. This happens if you have possible outliers on the low end, or there are possible outliers on the low end. So the mean is less than the median. So the median is the center of the data. Here's most of the data. If you've got some data values on the low end, it is going to pull the mean down and it will lower the mean. So the mean will be less than the median. All right, last, what if your data is skewed right? So skewed right means that you might have that tail on the right end of your data. So, you've got most of your data here, but then you've got that tail off on the right. So here's kind of most of your data and it's skewed right over here. So that happens when you have possible outliers on the high end. So that means that the mean will be pulled higher. It's pulled higher by those high outliers. So the mean this time will be greater than the median. So essentially what we're talking about here is your data display, whether it's symmetric, skewed left, or skewed right, tells us some information about how the mean and the median compare. Symmetric data will have the mean and the median about the same value. If you're skewed left, the mean gets pulled that way, so the mean will be less than the median. If your data is skewed right, the mean gets pulled to the right, and now your mean is greater than the median.